Question number 1. Green light of wavelength 4.42 into 10 to the power minus 7 meters is observed in the emission spectrum of hydrogen. The energy of one photon of this green light is. Here we have to use E equals HF. As frequency is not given, we have to derive frequency, which is equal C equals F lambda. Therefore, F equals C over lambda. So if we substitute this into the equals HF equations, you get E equals HC over lambda is equal to 6.62 into 10 to the power minus 34 joules second into 3 into 10 to the power 8 meters per second divided by 4.42 into 10 to the power minus 7 meters. Simplifying this gives us 4.5 into 10 to the power minus 19 joules. As all the answers are given in kilojoules, we have to convert this by multiplying it by 10 to the power minus 3. Therefore, the answer is 4.5 into 10 to the power minus 22 kilojoules. And the answer is 4. Question number 2. Which one of the following atoms in its gaseous state will liberate the largest amount of energy when it gains an electron? Gaining an electron is the electron affinity. So, when gaining an electron causes the ion to achieve a more stable configuration, the amount released is more, amount of energy released is more. Whereas, if you want to add an electron to an already stable configuration, then you have to provide energy. Therefore, neon, which is already complete with a complete energy level, is endothermic to gain its first electron. Same as magnesium, because magnesium has a filled S2 energy level. Now we come to sulfur, phosphorus, and sodium. Sodium has 3s1. Phosphorus has a partially filled p orbital. Partially filled p orbitals in group 5 are stable enough. Therefore, the energy released by phosphorus is less. Now sulfur. Sulfur is found in the 6th group, whereas sodium is found in the 1st group. So if we consider these two, here E over R ratio comes into play. So the one with the higher E over R ratio will release more energy. Therefore, sulfur is the answer. Sulfur has a higher E over R ratio. So sulfur has 6 electrons in its outermost energy level divided by its radius, which is smaller than sodium, because along the period the radius of the atom decreases. Therefore, the answer is 1. Question number 3. What is the IUPAC name of the compound X? This compound, as you can see, is an ester. So ester, you start by naming the group attached to its alcohol side. So this is ethyl. So we can exclude answers 2 and 3. And naming, and there is no hyphen between ethyl and the other side, so 4 can be excluded as well. So now it is in between 1 and 5. As the ester carbon has the highest priority, we start numbering from here: 1, 2, 3, 4, 5, and now we start naming the groups. So we have a formyl group here, a cyano group here, and an alkyne, a triple bond here. So this will be ethyl, 2 cyano, 2 formyl, pent, because it has 5 carbons, and 4 pentinoate, because the triple bond is placed on the 4th carbon. This can also be named as pent 4-inoate, like pent 4-inoate. Therefore, the answer is 5. Question number 4. Which of the following statements regarding size of ions formed by S and P block elements is false? Cations are always smaller than the neutral atoms. This is true, as now they have released an electron. The protons exert a larger attractive force towards the rest of the electron, making the ion smaller. So this is true. anions are always larger than the neutral atoms. Similar explanation, whereas now they have gained an electron and now there are more electrons than protons, and the attractive force of proton is not as strong as before. The size of cations decreases from left to right across a period. This is similar to how the size of atoms decrease along the period, because the more electrons you release, the smaller the ionic radii gets. Fourth one, the size of anions increases from left to right. This is false. As for anions, they have gained more electrons as they move from left to right. Therefore, the radius will be larger. For example, if we take a look at three elements, let's say N3 minus, O2 minus, and F minus. Here we have 3 more electrons, so it will be larger. This will be small than that, and F minus will be even smaller. Therefore, this is false. The size of anions formed by elements of the second period are larger than the cations formed by the elements of the third period. Here, the anions and the cations have the same configuration, that is that of neon. So the only difference is protons. The higher the protons, the greater the attraction. Therefore, this is correct as well. The answer is 4. The sets of quantum, question number 5. The sets of quantum number associated with the last 2 electrons of an atom in an element are 3, 0, 0 plus half and 3, 0, 0 minus half. The element is. The first number represents the main energy level, so which is 3. 0 represents the sub-energy level. Which is the angular quantum number. So here this is S, because 0 is S, 1 P, 2 D. So this is S, and plus half and minus half indicates the 2 electrons present in this orbital. So the last shell is 3s2. This is found in magnesium. The answer is 3. Sixth question. A 0.6 gram sample of potassium iodide was dissolved in water and excess potassium iodide was added. The minimum amount of 3mHCl required to completely convert potassium iodide to iodide is. So we can write the balanced chemical equation, which will be 6H plus IO3 minus plus 5I minus, giving 3I2 plus 3 water. Iodine in iodide gives us I3 minus. As there is excess iodide present, we can just disregard this and directly calculate for I2, because even if we do consider it, it will be I2 plus I minus, giving us I3 minus, which is 1:1. So here we have the ratio between H plus and iodate as 6:1. So the moles of iodate multiplied by 6 will give us the moles of H plus. So we have 0.6 grams into 6 divided by 214 grams per mole, which is equal to the amount of HCl. They want us to find the volume and they have given us the concentration. So this will be equal to 3 moles per cubic decimeter into volume divided by 10 to the power 3, because the answers are given in cubic centimeters. Solving for this will give us 5.6 cubic centimeters. Therefore, the answer is 3. Question number 7. At 25 degrees Celsius, the solubility product Ksp of manganese sulfide is 5 into 10 to the power minus 15 moles squared dm minus 6. The acid dissociation constants K1 and K2 for hydrogen sulfide are 1 into 10 to the power minus 7 and 1 into 10 to the power minus 13 respectively. The equilibrium constant Kc for the reaction MnS plus 2H plus, giving Mn2 plus H2S. So first we have to find out what we need. So here we have Kc, which is equal to Mn2 plus H2S divided by H plus. Here Mns is disregarded because it's solid, therefore does not come into the equation. So now we'll find out H2S. H2S, K1 will be H plus, for this equation will be H plus Hs minus divided by H2S, and for K2 it will be H plus H2 minus divided by Hs, and the KSP for MNS is KSP equals Mn2 plus Aq into sulfide Aq. So if we take KSP divided by K1, K2, now when we simplify this, we get Mn2 plus H2S divided by H plus squared, which is what we want here. So Kc is KSP divided by K1, K2. If simplifying, it gives us 5 into 10 to the power 5, which is answer number 4. Question number 8. An organic compound A contains 39.97% carbon, 6.73% hydrogen, and 53.3% oxygen by weight. What is the empirical formula of A? So first here we take the mass percentage of each of these. We can just directly correlate it to mass, and then we divide it by the molecular weight, and we get 3.33 for carbon, 6.73 for hydrogen, and 3.33 for oxygen. And then we divide each of these numbers by the smallest number, which is 3.33. Therefore the ratio is 1:2:1, and the empirical formula will be CH2O, which is answer number 5. Question number 9. Which of the following statements is false regarding the chemistry of lithium and its compounds? 1. Lithium reacts with oxygen to gas to give Li2O. That's true. Li plus O2 gives us Li2O. Second one, lithium has the highest melting point among the group 1 metals. That is also true. The basicity of lithium hydroxide is less than that of sodium hydroxide. This is true because basic nature of hydroxide increases down the group. Number 4, lithium carbonate has the lowest thermal stability among the group 1 carbonates. This is also true as heat stability of carbonates increases down the group. Lithium gives us a red color. Therefore the answer is 5. Question number 10. The oxidation states of N1 and N2 in the most stable Lewis structure of F2NNO molecule is. So we have the most stable structure is F, N, and double bonded O and F here. So now if we, this is nitrogen number 1, this is nitrogen number 2. So if we find the oxidation state of this N and F, F is more electronegative, so +1 here, +1 here, and N 0. Therefore the oxidation state of this is +2. So we can exclude answers 2, 4, and 5. So it's 1 or 3. Here we have considering nitrogen and oxygen, oxygen is more electronegative. So we have +1 here and +1 here. 1 plus 1 again +2. Therefore the answer is 1. Consider the reaction CH4 plus CO2 giving 2CO plus 2H2. When 0.6 moles of CH4 and 1 mole of carbon dioxide were introduced into a closed rigid container of volume 1 cubic decimeter at 25 degrees Celsius, and the system was allowed to reach equilibrium, 0.4 moles of carbon monoxide was formed. The value of the equilibrium constant Kc for the reaction is. So Kc is going to be the products divided by the reactants. So, and stoichiometric coefficients become powers. So we have Kc equals carbon monoxide squared into hydrogen squared divided by methane into carbon dioxide. So initial moles, we have 0.6 moles of methane and 1 mole of carbon dioxide. And finally we have 0.4 moles of carbon dioxide formed, which means there will be 0.4 moles of hydrogen formed. Because the stoichiometric ratio of carbon monoxide to carbon dioxide and methane is 2:1, 0.2 moles of each of the reactants would have reacted to form these products. So we have 0.6 minus 0.2 for methane and 1 minus 0.2 for carbon dioxide, giving 0.4 and 0.8. So for Kc, if we simplify, if we substitute the values, it will be 0.4 squared into 0.4 squared divided by 0.4 into 0.8. Substituting this and simplifying this will give us 0.08, therefore the answer is 2. Question number 12. The chemical formula of diamine bromide or dicarbonyl hydride or cobalt 3 chloride according to IUPAC rules is. Here we name according to ligating atoms in alphabetical order within the formula. So we have Br, C, H and NH3. So for bromine, the ligating atom is Br. For carbonyl, it's C. For hydrogen, it's H. And for amine, it's N. So B, C, H, N should be the order. That order you can see here in number 4. 13th one. The following procedure was used to determine the sulfur content in a coal sample. A coal sample of mass 1.6 grams was burnt in oxygen gas. The SO2 gas formed was collected in a solution of hydrogen peroxide. This solution was then titrated with 0.1 moles per cubic decimeter sodium hydroxide. The volume of sodium hydroxide required to reach the end point was 20 cubic centimeters. The percentage of sulfur in the coal sample is. So the first reaction we have is S plus O2 giving SO2. Then we have SO2 plus hydrogen peroxide going to H2SO4 and H2SO4 reacting with 2 sodium hydroxide. So for this we have to work backwards. So you have 0.1 into 20 into 10 to the power minus 3. 0.1 is the concentration of sodium hydroxide and 20 into 10 to the power minus 3 is the volume. This gives us the amount of moles. So we have 2 into 10 to the power minus 3 moles of sodium hydroxide. Because of the stoichiometric ratio, we get 1 into 10 to the power minus 3 moles of hydrogen sulfuric acid. Then we have 1 into 10 to the power minus 3 moles of sulfuric acid giving us 1 into 10 to the power minus 3 moles of sulfur dioxide, which in turn gives us 1 into 10 to the power minus 3 moles of sulfur. 1 into 10 to the power minus 3 moles of sulfur will give us 32 into 10 to the power minus 3 grams. So if we solve for the mass percentage, we get 2%. Therefore, the answer is 2. Question number 14. Combustion of ethylene is shown in the following reaction. What is the value of delta H in kilojoules per mole if the combustion produces water in the liquid state rather than water in the gaseous state? So we have the equation first. We have C2H4 gas plus oxygen giving us carbon dioxide plus water gas. For this, the delta H is minus 1323. And next, if we take the equation to water gas going into water liquid. Now to simplify this to give us water liquid we have to multiply this whole equation by 2. So you have 2 water giving us 2 water liquid. Therefore the delta H is minus 44 into 2. So now the resultant reaction will be what we want here. So the answer for the delta H would be minus 1323 plus minus 44 into 2, which will be minus 1411 kilojoules per mole. The answer is 5. Question number 15. The vapor pressure of benzene at 25 degrees Celsius is 12.5 kilopascals. When an unknown non-volatile substance was dissolved in 100 cubic centimeters of benzene at this temperature, the vapor pressure of the solution was found to be 11.25 kilopascals. The mole fraction of the unknown substance in the above solution is. So let's assume the mole fraction of benzene when mixed is XA and for the liquid it's XB. Applying Raoult's law, we know that the vapor pressure of the mixture is equal to the mole fraction into the total saturated vapor pressure. So this will be equal to, so now we have to find XB. So XB is 1 minus XA. So we get P mixture equals 1 minus XB into P benzene. This is 11.25 kilopascals equals 1 minus XB into 12.5 kilopascals. Simplifying XB gives us 0.1, which is answer number 2. The 16th question, the volume of the acid and base was not given to work out concentration. Therefore, this was given as all. Number 17. The major product A obtained from the reaction given above is. So here we have a benzene ring attached to an alcohol and a carboxylic acid. Aqueous sodium hydroxide is a base. So sodium hydroxide will react with the acid. Alcohols are not acidic enough for sodium hydroxide to react with it. Therefore, there is no reaction for alcohol, whereas on the other hand, carboxylic acid will react with sodium hydroxide, giving COO minus Na+. Therefore, the answer is 3. Question number 18. The rate law for the reaction NO2 plus CO giving NO gas plus CO2 gas is rate equals K NO2 squared. A small amount of carbon monoxide was introduced to a closed rigid container in which this reaction is taking place at a given temperature. Which of the following statements is true regarding the changes that would take place? Rate equals K NO2 squared. Here K is the reaction constant, the rate constant. Rate constant only depends on the temperature, therefore K will not change. So the answers 4, 3 and 1 can be excluded. So now we have to decide between 2 and 5. As we can see in the rate equation, carbon monoxide is not present in the rate equation. Therefore, the concentration of carbon monoxide does not affect the rate of the reaction. Therefore, both K and the rate of the reaction rate remain unchanged. The answer is 2. Question number 19. At 25 degrees Celsius, given that they have given the standard cell potential and the electrode potential for silver. The standard reduction potential for the half reaction for M is, so here we can use E cell equals E cathode minus E anode. Here the cell is 2.46 volts and the cathode is 0.8 minus E anode, and when we simplify for E anode we get minus 1.66 volts. Therefore the answer is 1. Here we decide the anode and the cathode by the standard cell equation. Here M has undergone oxidation. Oxidation happens at the anode, so that is what we need to find, whereas silver has undergone reduction. Therefore silver is the cathode. Question number 20. How many resonance structures can be drawn for the molecule N2O3? The skeleton is given here. So these are the 4 structures that can be drawn. We have 2 stable structures at the top and 2 less stable structures at the bottom. Even though the 2 at the bottom are relatively less stable, they can somewhat exist because the negative charge remains on the oxygen atom, even though there is a high charge distribution. So if the question had asked what are the stable structures, we have 2. But because they have asked how many resonance structures can be drawn, you have to include all the stable, unstable, less stable resonance structures as well. So in fact 7 resonance structures can be drawn for this with extremely unstable ones. But as an answer like that is not given, we go for this answer, which is 3, which is answer number 3, which means 4 resonance structures. Question number 21. Which of the following statements is true with regard to transition metals and their compounds? The electronic configuration of copper is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. This is actually false, as copper is 29 and it is 1s2, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10 and 4s1. Therefore this is false. Second one, all elements that have d electrons are transition elements. For an element to be a transition element, the last few electrons have to be d electrons. Therefore this is false. Third one, the electronic configuration of titanium in TiO2 is the same as that of scandium in SCCl3. This is true, as Ti4 plus and Sc3 plus are isoelectronic, which is 1s2, 2s2, 2p6, 3s2 and 3p6. So this is correct. So the answer is number 3. Number 4, acidity of the oxides of a given transition metal decreases with increasing oxidation state of the metal ion. This is false, as when oxidation state increases, it has a higher tendency to be more basic. 5. Transition metals in the 3D series can have the quantum number ml equals plus or minus 3. As we have seen before, the d orbital is represented by 2, so it can only have plus or minus 2, not 3. Plus or minus 3 is present in f orbitals. Question number 22. Sorry. the equilibrium PCl3 plus 3 ammonia giving PNH3 2 thrice plus 3HCl exists in a closed container at a constant temperature. If the volume of the container is increased by keeping the temperature constant, which of the following is true regarding the changes that could take place in the rates of forward and reverse reactions? As the temperature is kept constant, the kinetic energy of the system remains unchanged. Therefore, the main factor that influences the rate of the forward and backward reactions is the frequency of collision of gas molecules. When the volume of the container is increased, the number of collisions taking place in a unit area in a unit time decreases, resulting in the decrease of both forward and backward reactions. Therefore, the answer is number 3. 23. When solid ammonium chloride is dissolved in water at 25 degrees Celsius, the temperature of the solution decreases. Which of the following is true of enthalpy delta H and delta S for the process? As the decrease in temperature shows that it is an endothermic reaction, which means the enthalpy change is positive. So we can exclude answers 4 and 5. Dissolution of ionic compounds such as ammonium chloride in water is spontaneous, which means delta G equals delta H minus T delta S. We know that delta G is negative or 0 for it to be spontaneous. Delta H is given as positive. Temperature is always positive. And now they have asked for entropy. If entropy was positive, no, first we'll take negative. If entropy was negative, positive into negative here will again give a negative. And this negative into this negative will give us a positive. And these two positives cannot give us delta G as negative. So delta S has to be positive. Then these two positives gives positive, and then we have these two giving another negative, and this is possible if T delta S exceeds delta H or is equal to delta H. Therefore, the answer will be 1. 24. Which of the following statements is false regarding 3D transition metals and their compounds? 1. Oxides of some metals are amphoteric. This is true. For example, manganese has basic, acidic as well as amphoteric oxides. Some metals and metal oxides are used in industry as catalysts. True. Example, iron oxide, MnO2. Third one, electronegativity of 3D transition metals is higher than 4s metals. This is also true. Number 4, only one element shows the oxidation state of +7. This is true. This element is manganese. Number 5, oxyanions such as MnO4- and Cr2O72- are resistant to reduction. This is false. As these are good oxidizing agents, they easily undergo reduction. Therefore, the answer is 5. The major product obtained when the compound above is reacted with excess CH3MgBr and then hydrolyzed is. Let's look at this compound in two parts, the left part and the right side. So the left side, here we have CH3MgBr attacking the carbonyl carbon and forming OMgBr and CH3 group being added. It is then hydrolyzed to give out OH, hydrolyzed to give OH. So looking at this, we can exclude answers 1 and 3. Next, we look at the structure on the right hand side. So here we have an ester. CH3MgBr attacks the double bonded carbon here and forms OMgBr, and a CH3 group is added. When hydrolyzed, this OMgBr, the MgBr is removed and OH is formed. Here the electrons from the hydrogen bond are attracted to the oxygen atom, and the electrons from the oxygen go into the bonds, go into the CO bond, and the C2H5O group is removed. This causes the formation of a ketone here and the removal of C2H5OMgBr. CH3MgBr again attacks the carbonyl carbon here and, similar to the above reaction, forms this compound, and then hydrolysis gives this compound. So the final product will be answer number 5.